All right, so we're going to finish off section 6.3, I believe it is. Yep. And so let's point out first something very important. To verify identities with half angles, apply half angle identities first. That means that we have a choice from between left-hand side and right-hand side. Whichever side has a half angle identity, that we apply a half angle identity, that's where we want to start. All right, let's take a look at an example here. So example 1 says if sine x is negative 3/5 and x is between pi and 3 pi over 2, right, greater than pi, less than 3 pi over 2, find the exact value of each, and the each are sine x over 2, cosine x over 2, and tangent of x over 2. Okay, so let's do one of these. Okay, so this will be sine of x over 2 is, I don't remember actually right now, so it's plus or minus square root of 1 minus cosine x over 2. Okay, plus or minus square root of 1 minus cosine x over 2. All right, so now that means I need to know what cosine x is. And I know what sine x is, but I don't know what cosine x is. But remember, cosine squared x is 1 minus sine squared x, which will be 1 minus 9/25, which will be 16/25. So cosine x then, cosine x will be plus or minus 4/5, right, the square root. All right. And now how will I know? Well, x is between pi and 3 pi over 2. So that'll tell me whether this is positive or negative. Between pi and 3 pi over 2, which is in the third quadrant, cosine x will be negative, right? So cosine x then is negative 4/5. All right, so this will be plus or minus square root of 1 minus negative 4/5. That'll be plus 4/5 all over 2. Right? Remember that 1 is 5/5, so this is plus or minus square root of 9/5 over 2. And to divide by 2, you can just think of multiplying by half. This will be plus or minus square root of 9/10. And if we apply the square root, this will be plus or minus 3 over square root of 10. We want to rationalize, so this will be plus or minus 3 square root of 10 over 10. Now, we need to determine if it's positive or negative. Which is it, plus or minus? This is for x over 2. So remember, x is between pi and 3 pi over 2. So if we divide each of those parts by 2, or take half of them, then x over 2 is greater than pi over 2 and less than 3 pi over 4. Okay, pi over 2 and 3 pi over 4. Where is that? Well, that's in quadrant 2. In quadrant 2, the sign is positive. Okay, this is quadrant 2. In quadrant 2, the sign is positive. So our answer is the positive 3 square root of 10 over 10. Okay, all right. How about the cosine of x over 2? Again, in quadrant 2, it'll be positive. So this will be negative. I'm sorry, negative. We already know, right? Square root of 1 minus, or plus, is it? Yeah, 1 plus, I'm sorry. 1 plus cosine x all over 2. This will be negative square root of 1 minus 4/5 all over 2. This is negative. 1 is 5/5 minus 4/5 is 1/5 over 2, which is 1/10. Square root of 1/10. We can take the square root of 1, right? This is negative square root of, which is 1 over square root of 10. And if we rationalize, this is negative square root of 10 over 10. Okay. All right. And I'm going to leave the tangent of x over 2. You know what, let's finish it. So tangent, because I know sine and cosine, will be sine of x over 2 over cosine of x over 2. That'll be 3 square root of 10 over 10 over negative square root of 10 over 10. right? So we have the tens cancel. I don't know if you guys remember us talking about this before, when you have the same denominator in complex fractions. And so we have 3 square root of 10 over negative square root of 10. That'll be negative 3. All right. Let's see. Find an exact value for each. Cosine of 15 degrees. We can think of cosine of 15 as 30 over 2. So this will be, the cosine is 1 plus, and it'll be a positive, right? 1 plus cosine of 30 degrees all over 2. Yeah? All right. Yeah, let's do this one. And then we'll leave tangent of 7 pi over 12 to finish off. All right. So this will be 1 plus, what's the cosine of 30? So the square root of 3 over 2. Square root of 3 over 2 all over 2. This is 2 plus the square root of 3 square over 2 over 2, or multiply times 1/2. This will be square root of 2 plus square root of 3 all over 4. Yeah. So that'll be square root of 2 plus the square root of 3 on top over 2 on bottom. All right. And we can, in class, we can check this by just checking the cosine of 15 on a calculator and checking to see if it matches with this number. Okay. What about tangent 7 pi over 12? I forgot what the expression for tangent of x over 2 is. It is plus or minus 1 minus cosine x over 1 plus cosine x. Is it square root of? Indeed, plus or minus square root of 1 minus cosine x over 1 plus cosine x. All right, and this is x would be 7 pi over 6. Right, so this will be plus or minus square root of 1 minus cosine of 7 pi over 6 over 1 plus cosine of 7 pi over 6. Let's just finish this one off. All right, so this will be, do we know if it's plus or minus tangent of 7 pi over or 12? Well, it's a little bit more than pi over 2, so the tangent will be negative in quadrant 2. So we then have now know that it should be negative. So this will be negative square root of 1 minus, and do we know what the cosine of 7 pi over 6 is? 7 pi over 6, cosine is negative root 3 over 2. So this will be plus root 3 over 2 over 1 minus root 3 over 2. All right, this will be, if we multiply times 1 plus root 3 over 2, we can multiply times 2 over 2, right? Or we can multiply times 2 over 2 first. Okay, so I'll multiply times 2 over 2. Okay, this will be 2 plus root 3 over 2 minus root 3. All right, this will be negative square root of, and now I'm going to multiply times 2 plus root 3 over 2 plus root 3. All right, so this will be 4, 2 times root 3 plus 4 root 3 plus 3 all over 4 minus 3, which will be 1. This will be negative square root of 7 plus 4 root 3. Yep, and that's as far as I can go. Okay, and we'll check that. If you work it and get a different answer, let me know in class. We'll check it again in class, and again we can use a calculator to check if tangent 7 pi over 12 corresponds to this expression. Okay, all right, I'm going to leave it at that, and we can again check this in class. All right, that'll be the end of 6.3.